So my name is Dirk. I'm from a company called DEKA Research, and I lead the autonomous robotics team for DEKA. So DEKA is an interesting company. We've had about 30 years worth of experience applying computer vision and robotics in real-world application. We've got 800 plus incredibly smart engineers and incredible technical resources. And the thing that makes DEKA successful is a little bit the way that the company is organized. We're very well vertically integrated. We basically have electronics, mechanical, and software engineers all combined in the same place, all working together, and then have very good rapid prototyping resources available. So as my teenage daughter tells me every day when I ask her something, her answer is always, "Dad, it's complex." And we work in a really complex world. And although I know nothing about solving teenagers' complex problems, I've had a little bit of experience with applying sensors and sensor solutions in real-world situations, and it becomes complex very quickly. So what causes this complexity is, like some of the previous speakers mentioned, is sensors have inherent physical limitations, whether it's cameras that's sensitive to light or radars that's got sparse representation. All of our sensors have weaknesses. And simultaneously, the algorithms that we apply to extract information from those sensors have weaknesses as well, whether it is AI sensors that have certain accuracies and reliability, or whether it's even traditional computer CV program software that has limitations. So all of these things have weaknesses. And how do we overcome those weaknesses? We tend to stack sensors together. So we use radar and LiDAR and radar, and we use them in combination to try to overcome the weaknesses. And all of these, as you stack these sensors together, you add complexity to your system. This then causes us to have to look at real responses from sensors. So every sensor that's out there takes a certain amount of time to gather the information and present the data. So you can have cameras running at 60 frames a second, and you can have radars that can give you somewhere between 10 and 20 hertz, depending on how good your radar is. And you've got LiDARs that all of them has certain sample times that's important to them. And because of this, you have to combine those sensors sort of on time base. And the thing that we found out, sort of the hard way, is that the best way to combine the sensor information is to hardware sync sensors together. There is ways that you can sort of post-process the data, but if you sync them together, you know when those sensors start grabbing information. It makes just your whole problem a lot easier. And the other thing that we deal with very frequently as we deploy robots in real-world situations is that all of them runs off batteries. Everybody wants to run as long as possible. Everybody wants to run longer than what is actually possible. And because of that, you're limited by power. You're limited by the compute that you can actually run in the time that you have available. And that makes stuff challenging.